linear search. Linear search name represents its meaning, right? So what does that means? Search one by one, right? So that's what the linear search means. So what does that means? Given any particular array, let's try to take an example and understand. After that, maybe we'll go for the algorithm or else like program kind of thing, right? So given any particular array, right? So let's take an example. Suppose our array is like this, right? So any array is given. Suppose I have, so array is indexed from 0, you know, 0, 1, 2, 3, 4, 5. So this is my array, right? It contains some elements like 10, 5, right? 3, 20, 25, 35. Okay. So now my array contains how many number of nodes or how many number of elements? So n is the number of element if I'll ask you. So array index is 0 to 5. Try to understand, array index is 0 to 5, but how many element it contains? 1, 2, 3, 4, 5, 6. So 6 number of elements are there in that particular array, right? So n is 6, right? So that means I need to search. I need to search all these value, so inside this particular array only, right? Inside this array, right? I am not going to search in any of the other data structure, right? Okay, so let me, if I'll ask you, can you search 20, right? Now question is whether 20 is present in this array, right? Whether 20 is present in this array, right? And why we are studying, right? So I can, so somebody can ask, I can look into this particular array and see, yes, 20 exists. Then why I need to write an algorithm? So it is not about by you to look into it, right? So we are going to write a program because there is only 6 number of elements you can see and just immediately see. But whenever your data set is very large, suppose it is like thousands of record, maybe 10,000s of record, then 10,000 elements are there, then it will be very difficult for you to search one by one and see and find out. So it will be, if you write the program, then we can execute it and again it will give you the output whether that particular element is present or not, right? So that's where the linear search came into picture, right? So what it says, so if it is, it can be 10,000 or it can be millions of numbers as well, right? So whenever it comes to like this, so now the question is whether 20 is present in this array or not, right? Or not, right? So that's where the question, how you will solve this, right? So this is the basic fundamental thing, right? So this is known as array traversal, right? So if we'll go for linked list also, this procedure is going to be remain same, right? So what you will do, so you will start from this particular initial index. So you will start from here, right? You will see, you will take 20, you will see, okay, 20 is present in this index 0. Answer is no, there is 10. Okay, so it is not present here. Let's try to search in the next index. Since it is not there, so it is, we are going to search in the next index, right? So whenever we are going for next index, so is it 20? Answer is no, right? So this is also not 20. So then go to the next index, right? Go to the next index. Is it 20? Answer is no, right? Then what will happen? So then I will go to the next index. Is it 20? The answer is yes. So this is 20. I got a match. Yes, I got a match at this particular thing. So remember, so whenever we'll write the code, this will also going to help you. So once you got a match, right? Once you got a match, like 20, you got it. Do I need to search any other element after this? Answer is I don't need, right? I don't need to search. There could be, actually there is only 2 elements, but this array could have been 10,000 of numbers, right? So that's why it is very important. Once I got a match, I don't need to see whether I don't need to search it again, right? Like in a gathering, right? Like I have given you example. So once you are searching for an element, your friend, once you got a match, or you find that particular friend, so one of your good friend, then you don't need to search whether he exists somewhere else or not, right? Because you already found a match. So that's why you can stop. If you find him in somewhere, then we don't need to search everywhere else. So that's why in linear search, once you keep on searching one by one, and once you find a match that okay, this match has found, then no need to search all the other elements. You can return from here or you can break from here because you found that particular element or you found that particular friend, right? So that's the concept. So why I'm emphasizing that don't need to search, because accordingly you will write down the code also. So whenever you will write down the program, whenever you will write down the algorithm, once you find a match, you don't need to keep on searching. You can do a break at that particular point, right? You don't need to search further. So that's the main idea. Okay, so that's the main idea of the linear search. Okay, so this is the basics of the linear search. So let me write down, right? Write down the common algorithm, then we'll write down the program, then we'll do the analysis, right? So what will be the algorithm? So algorithm is just basic simple steps. Start from the leftmost element or the 0th index, right? Start from the leftmost element, right? And compare the element one by one, and compare, okay, element, each element with this particular input element. Suppose this value is something, right? Data or X, maybe this is data. Okay, so this is X or data. Suppose this is data equal to 20. So try to match, start from the leftmost element, right? Just try to match one by one, and keep on continuing and key for each element in this particular array. Suppose this array name is ARR, right? So what you will compare? So you will compare ARR of I and the data, right? If they are equal, right? You will keep on comparing, right? So if X matches, right? So if we got in at any particular time, if you got the match, then you immediately return it, right? Right? So if X does not, suppose you are searching for 45, then you will not get a match, right? So you will try to search it here. 45 no, 45 no, 45 no, 45 no, 45 no, 45 no. In this case, I did not find a match, exact match for that particular data which I am searching for, 45. So in that case, you will return that index. Where index? Maybe -1, because -1 means there is no such index exist. So that's how the algorithm will look like, right? That's how the algorithm will look like. Okay. So let me just let me just write down the algorithm here. We'll also write down the code in any of the language, so you can implement it any of the language, the format I will give. If you are good in C, you can implement C++, Java, Python, any language is good for you. So you can just look into this, but let's write down the algorithm first, right? Or the approach, right? So basic steps. So what is algorithm? It is just sequence of steps which is having some like objective, right? Step one is what? I will search, right? Start from the leftmost element of the array, right? One by, or start from 0th index of the array ARR, or it can be any name, right? ARR, okay? And compare one by one, right? And compare the ARR of I, or compare the element in the ARR, okay? Compare data, okay? Let me put it data. Compare this data, or maybe X, whatever, compare data with each element in ARR, right? Each element in ARR, right? Each element in ARR, right? Or maybe you can put ARR of I, that is fine. If you are writing ARR of I, don't write it, because ARR of I is ARR, okay? So what I'm trying to say, start from 0th index and try to compare the data. Data is not actually like put it in single quote, or you can make this as a X. Compare this data with each element in ARR. Each element, like we take 20 as the data, we compared it, yes, matched. Then the second step, what it will be? So when you are comparing this, either you will match or it will not match, okay? At any point of time, right? At any point of time, if we got a match, if we got a match, right? So at any point of time, you can write the second time, at any point of time or point of any at any step, right? If at any step, right, at any step we got a match. Okay, so when I say we got a match means what? ARR of I, I'm just writing ARR of I equal to data. This is the match. That means if we got a match, we can immediately return that index. We can immediately return that index, right? In the third step, what you can do, or in the same step, okay, return index, right? Return that particular index, okay? So return that particular index, okay? So this is the second step, okay? So what about the third step, right? Third step, I'll put it above, okay? So since third step, I'll put it here, okay? So what is the third step? If we do not get a match, right? If the data does not match with any element, then what will happen? So we are checking, right? So at any point, if you find a match, return that index. Like here, you will not return 20. Try to understand. You will return the index. That means third index contain that element 20. So that's why you will return that index. But if you did not get any match, okay, that means your data, this data did not get a match with anything, right, or any element, right? Then you need to return -1. If so, if you can write, if data does not match with any element, right? If data, right, data means that X or whatever the value you are trying to search, right? If data does not match with any element, then return -1, right? So this is what the algorithm, very pretty straightforward, right? Nothing much complicated, right? Simply we will start with the 0th index, try to compare. Okay, so now what will happen? So if I'll write down the algorithm for the same, I have written the algorithm. So before writing, let's write down the program, right? So if I'll write down the program, so how it will look like, right? So how the program will look like, right? How the program will look like. Let me erase these things, right? For now, let me erase these things. So how the program will look like let's talk about how the program will look like. So the program is pretty straightforward, this implementation of this particular algorithm, right? So what you will put, so you are looping, you are comparing one by one element. So that means you are putting a for loop, right? So that means, so for loop, any programming language you can use, but the basic syntax is going to be the same. Int I equal to 0, I less than n, I plus plus. Okay, so what does that means? So you will start from 0th index, you will keep on going until unless n minus 1th index, right? Because if it is 8 number of elements, so there are 7 index are there, 0 to 7. So that's why I less than n, right? So that's why. So it is very important. So this one is done. So if you'll try to map this algorithm with this program, right? So this step is for that, right? So this is not actually comparing, right? So this is just to looping. We are going to looping, right? Comparing will happen. So I will compare like this. If, so what I will write it here, right? So what I will write it here, right? So what I'll see, if my element is becoming the data, right? So this array, right? So if you know, this is my array, right? So some elements are there, right? 0, 1, 2, 3, 4, right? So 10, 5, 20, 25, 35. Suppose I'm searching 25. Is it matching with this one? Is it matching with this one? Is it matching with this one? So if ARR, suppose what is the array name? So ARR. If ARR of I equal to data, right? What does that means? At any point of time, if I got a match, right? So what I can do, I can immediately say that, okay, I got a match. I can return it from here, or else I can break it, right? There are different ways. So that depends upon you. You can return this index, right, from here, okay? Or else you can print, right? So I'll just print it here. If that depends which language you are using. Any language is fine. If you are using like C, then you can write printf. If you are writing Java, you can write just system.out.println. If you are using Python, you can use print. All these things you can use, but I'll simply write print. So it is not with respect to any language. I am not following any language. If whatever language, so that's why I'm not writing printf, right? I'm simply writing print, right? So element found what? Some message. Element found in index I. Okay. I means this I. So you need to print the value. That depends upon which language you are using. But anyway, so what you are doing, so if you got a match, then you will just simply print element found in that particular index I. Okay, and then you have two choices. You will do a break or you can do a return, right? You can return. If somebody is calling this function, you can return from here. There is no need to print it. Okay, so what will happen, so this for loop started here and ended it here. Okay, so after this for loop, so what will happen, so you need to handle one more case, right? You need to handle one more case. What is that case? If I'm searching for an element, suppose I'm searching for 45, or else I'm searching for suppose 12. So you did not get a match, 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 you did not get a match. That means for all value you did not get a match. So in that case, what you should return? Because here you are returning this particular index I, right? Or you are just printing it and you will break it here. Break means it will not, if you got a match, then you will break out, you will come out of this particular for loop, right? So you need to check. So there are different ways you can do it also. So you will check if I equal to n. Try to understand what is this. Okay, I'll explain you, no worries. Then print element not found, maybe. Okay, element not found. Okay, or else you could have done, so return, here you could have done return I, right? It will return the corresponding index, and here instead of writing this, you could have done return -1. Simple. So at any point, if you finding any I, such I where this particular I is matching, okay, so then any issues you are facing, guys? Okay, I think it is good for others. So Selna, maybe you can just log in back. Let's see how it is going. Okay. Yeah, I'll just okay, okay, okay. Okay, I hope it is clear now. Okay, so what I'm saying, okay. So what I'm saying, so you could have written there. So there are different ways actually approach. So return I you can do, or else return -1, right? Or else what you can do, I equal to n, right? So let's understand this. What does this means? If I equal to n, so what does that means? I did not break from in between, right? So that means I tried to search with 0, 1, 2, 3, again I plus plus I n, then it has gone till nth location. So that's why I is n. That means element is not found, right? So that is the algorithm, right? Or that is the program. Okay, so this is the way of implementation of the linear search. Just 1 second. Okay, so this is the implementation of the linear search. Okay, so this is the basic understanding, right? And this is the algorithm. and this is the like the program, right? You can implement in any language. Now the question comes, right? Now the question comes, what is the time complexity, right? I'll erase these things. I assume that you have taken note, or else let me erase this. Okay, so what is the time complexity, right? So what is the time complexity? Okay, okay. So now tell me, what is the time complexity? So let me talk about different time complexity. One is like maybe best case time complexity. Who don't know what is time complexity and all, so that is fine, so no worries. So I'll just explain you in details in some of the class, but for now, so what is this? So this is the number of steps the operation is executing, right? So how many number of steps it is executing, right? So if what is the best case means, what is the best case? Best case means I have an array, right? So I have an array, right? Suppose I have an array, so this is my array, and 10, 5, 12, 25, 35, something like that, right? This is ARR, and I am searching for a data, so which is like 10, right? So that is my best case, right? So I am searching for a data, so which is 10. So what will happen? So immediately once I go to this array, immediately I'll get a match. I don't need to search it again and again and again, right? So that means same goes for you, right? So you are in a party, or you are in a program, or you are in a somewhere, and you are looking for your friend, and once you enter to the gate, oh, you found your friend. So that's where you are lucky. Okay, that is the best thing, best time complexity. You did not spend any time to searching of your friend. So you asked your friend, just stay in the gate, right? Or maybe by luckily you found it in the beginning, right? So that is known as the best case scenario, right? So in the best case, you are going to search in a maybe 10,000 number of array elements are there, but still you got whatever the data you are searching, you search, find it in the beginning of the array. So that's why the best step time complexity, if you know, so that is going to be big of 1, right? So this is going to big of 1, right? This is going to big of 1. Okay, so now coming to maybe worst case time complexity, right? Worst case time complexity, right? We'll go for average case. There are 3 cases generally. So one is best case, worst case, and average case, right? Let's go for the worst case time complexity. So what is the worst case? What is the worst case time complexity? So worst case means, so you try to search for every element, but still you were not able to find, right? So what happened? Suppose your friend is not in the party. He told you that he will come, but still he did not come, and you did not realize that he never come, because he told that he will come due to some emergency or something. He did not come, but still you searched each and every person in that particular party, and you did not find him. So that's the same case, right? Or else maybe you searched your friend and you find after searching every place, right? At the last you find it. You search each and every place, and the last you find. So similarly, suppose I am searching this data instead of 10, so which was the best case. Suppose I am searching for something like maybe 45, right? So what will happen? I don't know whether this element present is or not. So that's why I need to keep traversing each and element. So I'll search, is this 45? No. 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 That means this element does not exist. Or else there is one more situation. Suppose I'm searching for 35. So I'll search this element, this element, this element, this element. Okay, yes, I found at last, right? So this could be one. Just don't think that this is only 5 element, right? So there could be 10,000 elements. There could be 1,000,000 elements, right? So that's where this particular worst case will come into picture. And you can see, so how many number of how many number of comparison, right? So it is going to be for all I, it is going to happen. So how many times you will search? you will search n number of times, right? Because there are n number of elements are there. In this case, n is 5, right? You will search 5 element. One element search, second element search, third element search, fourth element, fifth element. So 5 times you are going to search, right? So that's where the time complexity is going to be order of n, right? So whenever you talk about the worst case. So what is the average case, right? So what is the average case? So average case, let's try to understand, right? So what is the average case, right? So average case means in an average, so how many number of times you, so how many, what is the probability of finding your friend, right? Suppose, so you are on an average, suppose you are saying that you can find it here. So if you will talk about the average case, you will put n number of times, right? You'll put n number of times, right? So that means maybe, so you are running n number of times and you are saying for n number of times the elements is found in different position. That means first time I am searching which is found at one position, suppose immediately I found, and I run one more time. I run this particular linear search one more time for another element, so which is found in second position. That means two comparison. So here I found means only one comparison. Here I found means one comparison, two comparison. So similarly, I will keep on doing third, fourth like this way, right? So I will keep on doing this, and maybe n number of times I'm doing it. So the average will be, suppose I found element first time, second after second search, third search, fourth search, n number of times, right? So divided by n, because I simulated this particular program for n number of times, right? And so that's why 1 plus 2 plus 3 plus 4 plus dot dot n divided by n. So which will be what? So if you remember, right? So this is the formula. So what is the formula for this 1 plus 2 plus dot dot? So this is the AP. So if you remember, so this is going to be n into n plus 1 by 2. If you remember, right? This is the formula 1 plus n. So divided by n. So this is still going to be there divided by n. So that's why this n will be cancelled, right? So this n is going to be cancelled. So this is going to n plus 1 by 2. So this is the answer. Okay. And if you know, if it is n plus 1 by 2, so this is actually big of n, right? So big of n, because you can, so this is going to be n by 2 plus 1 by 2. 1 by 2 you can discard, and n by 2 is nothing but big of n. So what is the time complexity? Then we got it. So in best case, it is time complexity is order of 1. So in worst case, this is order of n. In average case, we got it like this mathematical formulation, because in average case means we'll run that particular test for n number of times, and I will think every possibility, right? So first possibility is that okay, I will got a match at first position. Second possibility is that I will get a match at second position. Third possibility is that I'll get a match at third position. So n number of times I will run. Last time I will match at last position. So that's how it gone from 1 to n. So since I'm running for n number of times, so divided by n, because I need to find out the average, right? So that's why I find it, and this is a simple mathematical formula n into n plus 1 by 2, and divided by n was that this n is going to be cancelled, and after that it is going to be n plus 1 by 2, so which is nothing but n by 2 plus 1 by 2, so which is order of n, right? So so that is the whole about the linear search, right? So yeah.